Welcome to this deep dive, and we're going to be looking at the life of physicist Paul Ehrenfest.
Okay.
You sent us a biography.
Yes.
And we're going to kind of dig into who he was, what he accomplished, and why he's still relevant today.
Sounds good.
And there's even a touch of tragedy to his story.
Yeah.
Which I always find makes things more interesting.
Sure.
We're talking about the early 1900s, a time when physics was being completely upended.
Yeah.
It must have been an incredible time to be alive and working in that field.
Well, absolutely. It was Yorgo Schneeppet who wrote the biography you provided, really captures that energy and excitement of that period. And Ehrenfest was right in the thick of it. Yeah. Born in Vienna in 1880 to a Jewish family, he was fascinated by science from a young age.
So a budding scientist from the start. I'm guessing his education played a big role in shaping his path.
Absolutely. Schneeppet details how Ehrenfest studied under some of the biggest names in physics and mathematics at the time. Ludwig Boltzmann, the pioneer of statistical mechanics, and David Hilbert, a leading mathematician, imagine being in their lectures.
Wow, yeah. It would be like taking a master class from Einstein.
Right.
So he was clearly surrounded by brilliance. Did he stay in Vienna?
No, he eventually became a professor in Leiden in the Netherlands, and what's fascinating is that he actually turned Leiden into a major center for physics research.
Wow.
Schneeppet really emphasizes that Ehrenfest wasn't just brilliant himself, he was incredibly good at explaining things.
So he was drawing people in and helping them understand these complex ideas. That's a talent in itself, and it's interesting because you often hear about these geniuses who are brilliant but can't communicate their ideas effectively.
Effect.
But Ehrenfest was different.
Exactly, and that made him so crucial in bridging the gap between what we could call classical physics and the mind-blowing world of quantum mechanics that was emerging. He was able to make these new, often counterintuitive ideas understandable to others.
Okay, so he's explaining quantum mechanics, but what about his own contributions to physics?
Yeah.
I know there's a theorem named after him, Ehrenfest's theorem. What's that all about?
Good question. Now, we don't want to get bogged down in the math here. But the key idea behind Ehrenfest's theorem is this. It shows how the behavior of these tiny quantum particles, when you average them out over time, starts to look a lot like the familiar laws of motion we see in everyday life.
Okay.
Think of it like a pendulum swinging at any given moment. You might not be able to predict exactly where it will be, but you can predict its average position over time.
So it's like connecting the dots between the quantum world and the world we experience that makes it seem a little less intimidating.
Precisely. And Schneeppet points out that this was hugely important at the time because it helped people accept this strange new theory of quantum mechanics. It showed that it wasn't completely disconnected from the physics they already knew.
It's like he provided a bridge between the old and the new. That makes sense. But didn't he do other work besides this theorem?
Oh, absolutely. Schneeppet also highlights his work in statistical mechanics and thermodynamics, particularly his research on how systems change from one phase to another, like water turning into ice, and how they behave near those transition points. These points, what physicists call critical points, are where things get really interesting.
Okay, so we're talking about transitions and thresholds. Can you give me an example of how that kind of research has applications today?
Sure. Imagine you're designing a new material that needs to withstand extreme heat. Understanding how materials behave near their critical points is crucial for creating something that won't, say, melt or crack under pressure. That's just one example of how Ehrenfest's work in seemingly abstract fields like statistical mechanics has real-world applications.
That's fascinating. It really shows how these seemingly theoretical ideas from a century ago can have such a tangible impact on technology today. Speaking of groundbreaking ideas, I know that Ehrenfest was involved in those famous early debates about quantum mechanics, especially the ones between Einstein and Bohr. Wasn't he friends with both of them?
He was, which is remarkable considering how different their views were.
Right.
Schneeppet actually describes him as something of a referee in their arguments.
Yeah.
He was constantly pushing them to clarify their thinking and find common ground.
Wow, it must have been quite a balancing act to be friends with both of these intellectual giants while they were battling it out over such fundamental questions. What was his own stance on quantum mechanics? Did he fully embrace it?
That's where things get even more interesting. Ehrenfest actually had his own doubts about certain aspects of quantum theory. He was particularly troubled by the Copenhagen interpretation, which is the most widely accepted interpretation of quantum mechanics.
So even while helping to explain and popularize quantum mechanics, he wasn't completely sold on it himself. That's a nuanced perspective you don't often hear about.
Exactly. And Schneppet really emphasizes that Nuance Ehrenfest was a complex thinker who wasn't afraid to challenge the status quo, even when it came to his own field.
Right.
But he wasn't just a critic. He was also a brilliant teacher and mentor.
We touched on that briefly, but I'd love to hear more about his role as a teacher. What made him so special?
Well, Schneppet repeatedly mentions how Ehrenfest wasn't just a genius in his own right. He was incredibly skilled at bringing out the best in others. He had a knack for explaining complex ideas in a way that made them accessible and exciting, and his enthusiasm was contagious.
So it wasn't just about rote learning in his classroom. It was about inspiring students to think critically and creatively.
Yeah.
Did he have any particularly successful students?
Oh, absolutely. Jan Tinbergen, one of his students, actually went on to win the first Nobel Prize in economics.
Wow.
Think about that. The impact of his teaching went far beyond just physics.
That's incredible. I'm starting to see why you find him so fascinating. It sounds like his classroom was an incredibly stimulating environment.
It was, and it went beyond just lectures. Schneppet also talks about these legendary gatherings called the Ehrenfest Colloquia,
Right.
where the leading minds in physics would come together to discuss and debate the hottest topics. Imagine a high-level scientific conference, but with more passion and intellectual sparring.
So he was creating a space for collaboration and the free exchange of ideas, which is so important in any field, but especially in science. It's clear that Ehrenfest's legacy goes far beyond his own individual achievements. But before we dive into that legacy, I have to ask, with all this focus on his work, what about Paul Ehrenfest the person? What was he like outside of the world of physics?
That's a great question, and it leads us to a more difficult aspect of his story.
Okay.
It's important to acknowledge that his life ended tragically.
Yeah.
He took his own life in 1933.
Oh, wow. I knew there was a tragic element to his story, but I didn't realize it was that tragic.
Yes, it's a reminder that even the most brilliant minds can be incredibly vulnerable and face deep personal struggles. Schneppet mentions that he faced increasing pressure in the rapidly changing world of physics and was also deeply affected by the rising anti-Semitism in Europe at the time.
Yeah, it's heartbreaking to think about the weight of those factors converging on him. It's a reminder that there's always more to the story than meets the eye. But let's shift gears for a moment and talk about his legacy earlier. We touched on how his work laid the foundation for modern quantum technologies. Can you elaborate on that?
Absolutely. Schneppet argues that Ehrenfest's work is incredibly relevant today, especially in fields like quantum computing, which has the potential to revolutionize everything from medicine to materials design.
Quantum computers are still so mind-boggling to me. It sounds like science fiction. How does Ehrenfest's work from a century ago connect to these futuristic machines?
Remember how we talked about Ehrenfest Theorem bridging classical and quantum physics?
Yes, the pendulum analogy.
Exactly. That bridge is crucial for quantum computing. These computers operate based on the principles of quantum mechanics, but we still need to understand and control them using the language of classical physics.
So it's like Ehrenfest provided the key to unlocking the potential of quantum computers.
In a way, yes. His work helps us translate between the strange world of quantum phenomena and the more familiar world of bits and algorithms that we use to program computers.
That's fascinating.
Yeah.
What about those other applications we briefly mentioned, like quantum sensors and communication networks?
Yeah.
How does Ehrenfest's work factor into those?
Well, Schneppet points out that his work in statistical mechanics plays a role there as well. For example, quantum sensors rely on the ability to measure incredibly subtle changes in quantum systems. Imagine a detector so sensitive that it can pick up the faintest whisper of a quantum event. That's what we're talking about.
So they're like super sensitive detectors.
Exactly. And understanding those minute fluctuations and transitions, which is what Ehrenfest excelled at, is essential for building these incredibly precise sensors.
And what about quantum communication networks?
Quantum communication relies on something called entanglement, where two particles are linked together in a way that defies classical physics. Even if they're separated by vast distances, they remain connected.
Wow.
It's like they have an invisible thread between them.
That just sounds like magic.
It does, doesn't it? And while Ehrenfest didn't work directly on entanglement, his contributions to statistical mechanics and his understanding of the probabilistic nature of quantum systems helped pave the way for scientists to explore and harness this phenomenon for secure communication. Imagine a network so secure that it's impossible to hack because it relies on the fundamental laws of quantum mechanics. That's the promise of quantum communication.
Wow, that's incredible. So his work wasn't just about specific discoveries. It was about creating a framework for understanding the quantum world, a framework that's still relevant today. It sounds like he was truly ahead of his time.
He was, and as Schneppat emphasizes, this is why Ehrenfest deserves to be remembered not just as a brilliant physicist, but as a visionary who helped shape the future of technology.
I'm really starting to see why you're so enthusiastic about him. It's incredible to think that his work is still so relevant in the 21st century, but it's not just about practical applications, is it?
No, it's not. Schneppat also highlights how Ehrenfest's deep concern with the philosophical implications of physics remains incredibly important today, especially as quantum technology advances.
So we're not just talking about building faster computers or more sensitive sensors. We're talking about grappling with fundamental questions about the nature of reality. What does it mean to measure something in the quantum world? Does quantum mechanics tell us anything about free will or determinism? Those are some heavy questions.
They are, and these are questions that philosophers and physicists continue to debate today, and Ehrenfest's work provides valuable insights into these discussions.
It's almost like he's still participating in those debates, even though he's been gone for almost a century.
That's a great way to put it, and that's what makes him so inspiring. He was more than just a brilliant mind. He was a deep thinker who wrestled with the biggest questions about the universe and our place in it.
And those questions are more relevant than ever as we enter this new era of quantum technology.
Yeah.
Well, unfortunately, that's all the time we have for this part of our deep dive into the world of Paul Ehrenfest.
Don't worry, there's much more to come.
Join us next time as we continue our exploration of the remarkable life and legacy of this unsung hero of physics.
Okay.
Welcome back to our deep dive into the world of Paul Ehrenfest. Before we move on, I'd like to go back to something you mentioned earlier, the tragic way his life ended.
Yeah.
It's a side of the story that we can't ignore.
You're right. It would be doing him a disservice to just gloss over that part of his life. And to Schneppat's credit, he doesn't shy away from it in his biography.
Yeah.
He really tries to paint a complete picture of the man, not just the brilliant scientist.
It's easy to get swept up in the excitement of his scientific achievements, but it's important to remember he was a human being with complex emotions and struggles just like everyone else.
Exactly. And, beyond those external pressures, we talk about the changing landscape of physics, the rise of anti-Semitism. Schneppat also points out that Ehrenfest was deeply troubled by some of the philosophical implications of quantum mechanics itself.
Now that you mention it, that makes sense. Quantum mechanics is mind-bending even for people who study it.
Right.
I can only imagine how challenging it must have been for him to reconcile those concepts with his own understanding of the world.
Schneppat talks about how Ehrenfest really struggled with the probabilistic nature of quantum mechanics. It's this idea that at the most fundamental level, things are not deterministic, but inherently random.
Right.
And for a lot of physicists, even today, that can be a tough pill to swallow.
It goes against our intuition about how the world works, right?
Yeah.
Cause and effect.
Right.
It's unsettling to think that randomness might be built into the fabric of reality.
It is, and Schneppat suggests that this philosophical struggle weighed heavily on Ehrenfest, especially as physics was evolving so rapidly around him.
I can see how that would be isolating, feeling like the ground is shifting beneath your feet while everyone else seems to be marching forward confidently.
Exactly, and to add to that, Schneppat also mentions the political climate of the time. Remember, this is the early 20th century. Europe was on edge, anti-Semitism was on the rise, and war was looming. It was a time of great uncertainty and fear, especially for someone like Ehrenfest, who was Jewish.
It's easy to forget the historical context when we talk about abstract scientific ideas.
Yeah.
But those external pressures must have added an immense burden to his already troubled mind.
Without a doubt, it's heartbreaking to think about all of these factors, personal, professional, and political, converging on him at once. And while Schneppat doesn't explicitly state this, I think it's important to remember that during this time, many Jewish intellectuals were facing increasing persecution. That context makes his story even more poignant.
It really does paint a very human picture of a man wrestling with enormous dilemmas, both intellectual and existential. It's a tragic end to what was clearly a brilliant life. But for now, I want to shift our focus back to his legacy, specifically how his work has impacted modern quantum technologies.
I'm happy to delve into that. Schneppat spends quite a bit of time discussing the impact of Ehrenfest's work on quantum computing, which is probably the most talked about application of quantum mechanics today.
It certainly is a hot topic,
Yeah.
and honestly, it's still pretty mysterious to me. How does his work from a century ago connect to these seemingly futuristic machines?
Well, remember we talked about Ehrenfest's theorem bridging classical and quantum physics?
Yes, I'm starting to see that theorem as a kind of Rosetta Stone.
That's a great way to think about it because quantum computers rely on the principles of quantum mechanics, but we still need to understand and control them using the language of classical physics. And Ehrenfest's work helps us do just that.
Okay, that makes sense. So he helped us translate the bizarre world of quantum phenomena into something we can work with. What about those other applications we mentioned, like quantum sensors?
While Schnepphat explains Ehrenfest's work in statistical mechanics is particularly relevant there, quantum sensors rely on the ability to measure incredibly subtle changes in quantum systems. These are changes that are happening at the smallest scales imaginable.
So we're talking about detectors that can pick up the tiniest fluctuations in the quantum world.
Exactly. And to build these ultrasensitive detectors, you need to understand those minute changes and transitions, which are exactly the areas where Ehrenfest's research excelled.
That's amazing. So it's not just about observing these quantum phenomena, it's about harnessing them for practical purposes.
Yeah.
What about quantum communication networks?
Now, those, as Schnepphat describes, rely on a particularly mind-boggling phenomenon called entanglement. This is where two particles are linked together in a way that defies classical physics.
Right.
Even if they are separated by huge distances, they stay connected. Any change to one instantly affects the other.
That honestly sounds impossible, like something out of a science fiction movie.
It does. And while Ehrenfest didn't work directly on entanglement, his understanding of the probabilistic nature of quantum systems helped lay the groundwork for others to explore and harness this phenomenon. Schnepphat argues that it's precisely this kind of work that's leading to the development of these ultra-secure communication networks.
So imagine a network that's impossible to hack because it's based on the fundamental laws of quantum mechanics. It's pretty wild.
It is, and it all goes back to those foundational ideas that Ehrenfest helped to develop. His work was about more than just specific discoveries. It was about creating a framework for understanding the quantum world, and that framework is still shaping technology today.
It's really amazing to think that someone from the early 1900s could have such a lasting impact. It makes you wonder what seeds we're planting today that might blossom into something incredible 100 years from now.
Mm-hmm.
But I feel like we've only scratched the surface of Ehrenfest's legacy.
You're right. There's so much more to explore, and Schnepphat goes beyond just the practical applications of his work. He also talks about how Ehrenfest's deep concern with the philosophical implications of physics is still relevant today, maybe even more so now as quantum technology advances.
That's a great point. We've been talking about things like faster computers and more secure communication, but there are bigger questions at play here, aren't there?
Absolutely. Questions about the nature of reality itself. What does it mean to measure something in the quantum world? Does quantum mechanics tell us anything about free will versus determinism? These are questions that philosophers and physicists are still grappling with today.
And it sounds like Ehrenfest was asking these questions way back then.
He was, and as Schnepphat highlights, Ehrenfest's work offers us a valuable perspective on these big philosophical debates. He wrestled with these ideas during a time when quantum mechanics was just beginning to be understood, and his insights continue to be relevant as we grapple with the implications of this strange and powerful theory.
It's almost as if he's still part of the conversation, even though he's been gone for almost a century. His ideas are still shaping the way we think about the universe.
I think that's a beautiful way to put it, and it's a reminder that scientific progress is not just about making discoveries, it's also about asking deep, challenging questions and engaging in open and honest dialogue about what it all means. And Paul Ehrenfest embodied that spirit of inquiry and intellectual honesty.
I'm really starting to appreciate just how complex and fascinating he was, both as a scientist and as a human being. And I'm eager to hear more about how Schnepphat wraps up his story.
Me too. There's still a lot to unpack.
Well, then let's not waste another moment.
Huh?
Stay tuned for the final part of our deep dive into the remarkable life and enduring legacy of Paul Ehrenfest. Welcome back to SOCAN. The deep dive exploring the world of Paul Ehrenfest has been a real eye-opener for me. I had no idea how much this one physicist, who I'd never even heard of before, contributed to science and the world at large.
I'm with you on that. And I think Schnepphat's biography does a fantastic job of not just explaining Ehrenfest's work, but also giving you a sense of who he was as a person.
Exactly. We've covered so much ground. His scientific achievements, his struggles, his legacy. But before we wrap up, I'm curious to hear more about the human side of Paul Ehrenfest. We know he was brilliant, but what else stood out about him?
Well, one thing Schnepphat really emphasizes is Ehrenfest's remarkable ability to connect with people. He wasn't just this isolated genius working in a vacuum. He genuinely cared about others and fostered a real sense of community.
Yeah, we've talked about his teaching and his role as a mentor, but it sounds like it goes beyond that.
It does. Schneppat describes him as deeply empathetic and compassionate.
Yeah.
He was known for his genuine interest in others and his willingness to listen. He would go out of his way to offer support, both personally and professionally.
It's interesting, isn't it, that someone who clearly battled with so much inner turmoil could also be so outwardly giving and supportive of others.
It is, and I think it speaks to the complexity of his character. Schneppat suggests that maybe Ehrenfest's own struggles, the things that tormented him, made him more sensitive to the challenges faced by others.
So he wasn't just a brilliant mind, but a true humanitarian as well.
Precisely, and that's why his impact extended far beyond physics. He created an environment where people felt comfortable sharing their ideas and supporting each other. He really fostered collaboration and a sense of belonging.
It sounds like he was the heart and soul of the physics community at that time.
In many ways he was, and I think that's what Schneppat really wants us to remember about Ehrenfest, that his legacy isn't just about equations and theorems, it's about the human connections he forged and the lasting impact he had on those around him.
Yeah, it's a great reminder that science is ultimately a human endeavor, driven by curiosity, passion, and a desire to understand the world, and it sounds like Ehrenfest embodied all of those qualities.
Absolutely, and that's why his story resonates so deeply. Even today, it's a story about the triumphs and struggles of a brilliant mind, a reminder that even the greatest geniuses are human, and that their legacies are often measured not just by their discoveries, but by the lives they touch and the communities they build.
I couldn't have said it better myself.
Yeah.
So as we conclude our deep dive into Paul Ehrenfest's world, what's the one key takeaway you hope our listener will walk away with?
I think it's this Ehrenfest story reminds us that science is a journey, not just a destination. It's about asking questions, challenging assumptions, and engaging in open and honest dialogue. It's about embracing the unknown and finding beauty in the complexity of the universe. And most importantly, it's about remembering that even in the face of great challenges, the human spirit can persevere and make a lasting impact on the world.
Beautifully said. And to our listener, we encourage you to continue exploring Paul Ehrenfest's world, dive deeper into his work, grapple with the philosophical questions he raised, and most importantly, reflect on the human side of science and the connections that bind us together in our pursuit of knowledge. Until next time.